All right, guys, let's get started. So this should not take too long. If you remember the properties of exponents, you'll understand the properties of logarithms, because logarithms, as I told you before, all logarithms mean, what's going on here? Oh, that's right. All logarithms mean is exponent, right? It's a different way of writing an exponential. It's the inverse of writing an exponential. So if you have a variable in an exponent, you can get it out by using a logarithm. So the properties of the logarithms are very similar to the properties of exponents. There's two key words you're going to need to know here. You're going to need to know how to condense, what does it mean to condense something? And then you're going to need to know what it means to expand. And you kind of heard this in science, right? Like the atoms are condensed. Like if you think of water, if you condense the atoms, it becomes ice. If you expand the atoms, it becomes steam. If you wonder how YouTube has so many videos of like 4K and all these large files, well, they do something called compression, is where they get the file and they condense all the zeros and ones going on in the computer and make it a smaller file. So to condense something means to make it smaller. To expand something means to make it larger. So those are the two things we're going to be doing using these properties. So we're going to talk about first the product property. So if I have a log with a base b, and I'm taking the log of a product, m times n, something times something. Well, if you remember, when I multiply the same base in exponents, like if I have 5 to the third times 5 to the seventh, what do you do to the exponents when you have the same base and you're multiplying, right? For exponent property, we would add them. This would become 5 to the 3 plus 7. We add the exponents. Well, the same thing here. When I have the log of a product, I am going to add the logs, or add the exponents. So the log base b of m plus the log base b of n. So we're adding the exponents, we're adding the logs. So that's the product property. Now, if I'm going to expand, that means I'm going to go from this compact version, and that equals this. If I'm going to condense, I'm going to go from this big version back to the smaller version. So that's all it means when they ask you to condense or expand. So let me show you what I'm talking about. So if I look here, 1, 2, and 3, the directions are condense into a single logarithm. So they're just saying, get your expression and, right, if I was in class, that's the sound effect, right? We put it together, we condense it into one single logarithm. So look here, we see that we're adding the logs. So as soon as you see that we're adding logs, we're adding exponents, the product property. So I'm going to put one log. They both have the same base 2. That's the only way I can do this. And since I'm adding the logs, that means these two numbers, that's the product of those two numbers based on our definition over here. Okay. So you should, at the end of this, be able to go from here to here. Or if I give you this, you should be able to go from here to here. Condense or expand. So right now we're condensing. So number 2, do the same thing. Mister, there's no base. You don't see a base. And remember, it's an imaginary 10. So now you see I'm adding the logs. So if I'm adding the logs, that means it's the product property. So I'm going to put the log. We know it's base 10, so I don't have to write it. So log base 10 of, we have 25 times 4, which is log base 10 of 100. Now, the directions do say simplify if possible. So if we go here, log base 10 of 100, remember, logs are asking what's the exponent with that base to give me that result. So if this is log base 10, this is basically asking what exponent of 10 gives me 100? And the answer is 2. And how do we know that? Because 10 to the second power is that result, if you remember from last week. Okay. If you give me just this, that's fine. You did condense it. But I want to see if you can simplify it beyond that if you understand what logs are asking, because all logs are asking is what is the exponent with that base to give me that result. And then number 3, we have log base 4 of 2x plus log base 4 of 4x squared. So we're adding 2 logs. So adding 2 logs, in your head, you're like, oh, that's the product property. So log base 4. And what are we taking the product of? This and this. 2x times 4x squared. So we can clean that up a little bit. So this is log base 4 of 4 times 2 is 8. X times x squared is x to the 3rd. There you go. And I don't think, let's go back. I don't think I simplified number 1. 7 times 4, we could actually do log base 2 of 28. Okay. Any questions there on condensing with the product property?
No.
Again, you guys good? Pretty easy?
Yeah.
All right, so now let's expand. Now let's go, I give you a single log. Can you separate them and give me 2 different logs? So log base 6, well again, there's a little 10 right here. Log base 10 of 6. We can go a bunch of different ways. There's a whole bunch of different ways we can go. Log base 10 of, I need a product in there. Since we're using the product property, I need to change this result into a product, okay? Because I don't have a product there, it's just a 6. So if I have a 6, I can change it to 6 times 1. I can change it to log base 10 of 3 times 2. This one makes more sense because we usually don't like to use ones in our products because 1 is kind of just 1. So I would do it like this. I'm going to separate it, and since I'm multiplying 2 things as my result, we're going to add the exponents or add the 2 logs. Log base 10 of 3 plus log base 10 of 2. And again, you don't have to write that 10 if you don't want to. And there I expanded this one log into that. Okay, let's try another one. Log base 7 of 45. Well, let's make 45 into a product. 45 is 15 times 3, or 45 is 9 times 5, right? Or 45 times 1, but again, we don't use that one. So either way, doesn't matter. So if I chose this one, this would become log base 7 of 15 plus, because we have a product there, plus log base 7 of 3. That's if I chose 15 times 3. If I chose this one, 9 times 5, then the result would be log base 7 of 9 plus log base 7 of 5. Those are 2 different ways to write it, and they're all equal. If I punch that into my calculator, give me the same answer. But that's expanding using the product property. Okay, last one. Oh, we actually give us a product. We have 5 times x here. So I have a product. So again, I'm multiplying, so that's a product. So I'm going to add 2 logs. Log base 2 of the first factor, 5, plus log base 2 of the second factor, x. And I'm done. All right, any questions about expanding using the product property? All right, your silence tells me no. Okay. So now let's go to the quotient property. Same thinking, but now we're taking the log of a quotient, of a division, right? M divided by n. And if you remember, with my exponent properties, if I had 5 to the 10th over 5 to the 3rd, how did I simplify this if I had my exponent properties, if you remember? I subtracted the exponents, right? Top exponent minus bottom exponent. Same thing with logs. When I'm taking the log of a quotient, I'm going to subtract the log of each m and n, okay? So this would become log base b of m minus log base b of n, right? Exponent minus exponent, just like we did here in the exponential properties. It's the exact same thing. It's just written in log form. So kind of the opposite of this, right? When I have the product, if I'm taking the log of a product, I add the logs. When I'm taking the log of a quotient, I subtract the logs. So let's try this. So let's condense, right? Let's make this into one single logarithm. And so the bases are the same, so we're good. So I'm going to put that together, log base 3. And since I'm subtracting, I'm going to have a quotient. And the first number goes on top. Second number goes on the bottom. And so let's simplify. So this is log base 3 of 24 divided by 8 is 3. And so what would log base 3 of 3 be? I mean, if you kept it like this, I guess that's okay. But if you understand what logs are, you should know that this equals a number. I have log base 3, and it gives me 3. So what's the exponent?
Wait, would it be what?
Yes, it would be 1. Because again, log is asking what's the exponent of that base to give me that result. And if we remember from last week, this to this power gives me that result. And so my answer is 1. Good job. All right, number 8, same base. So we can put them together. We are subtracting, so we know we're going to get a quotient because we're subtracting. Top, bottom. And so 15 divided by 15 is 1. So log base 2 of 1. And again, do we know what that is? 2 to what power gives me 1?
Can you repeat it?
2 to what power would give me 1? Like, what would this result in? 2 to what power gives me 1?
Wouldn't it be 2?
2 to the second power would be 4.
Oh no, 2 to the first power. I was thinking of the previous question.
It'd be 0.
0. Good job.
Oh.
Because anything to the 0 power is 1. Good job. Good job. Again, if you give me this result, that's technically correct. You did condense it. But you should, if you understand what logs are, be able to go further if you understand how this works. All right. Last one. Same base. So we can condense them. We are subtracting. So that means we have a quotient. X to the 9th on top. X to the 2nd on bottom. Oh, crazy. So now we have a quotient and a quotient. The quotient. So X to the 9th divided by X squared. Remember that rule we talked about? When I have the same base, what do we do to the exponents? We subtract them, right? So this becomes X to the 9 minus 2, which is X to the 7th. So this becomes log base 4 of X to the 7th. Any questions of the quotient rule? Condensing using the quotient rule. Okay.
Mister, can you go over number 9 again? I got distracted.
So we put the X to the 9th on the top, X squared on the bottom, right? And so this goes back to our rule I was telling you about, right? When you have the same base and you're dividing, you subtract the exponents. So that's what we're going to do here. I have the same base, X, and I'm dividing. So I'm going to subtract the top exponent minus the bottom exponent. X to the 9 minus 2, which become X to the 7th too large. X to the 7th.
All right. Thank you.
Mm-hmm. So now when we expand, we have a lot more options for expanding. So like later on when we do, when we're solving equations and stuff with this stuff, which I hope we can get to, but I don't know if we're going to do it because school's like ending soon. But let's look. So we want to expand this using the quotient property. So that means I need to change this into a division problem, into a quotient. And there pretty much is like an infinite amount of ways to do this. I mean, the most basic way is log base 8 of 4 over 1. That's one way to write it. Or I can write this as log base 8 of 32 over 8, right? That'll give me 4. Or I can write this as log base 8 of 16 over 4. That also will give me 4. We can keep on and on and on. So for our case, let's just pick a simple one. Doesn't matter. We could pick that one. And so since I have a division, right? I'm taking the log of a quotient. It's going to be subtracting 2 logs. Right, so I'm going to be subtracting 2 logs. So it'll be log base 8 of the top, 32, minus log base 8 of the bottom, which is 8. And I can stop there. And there you go, I expanded. Sometimes, like number 11, they'll just give you the fraction. So here's the fraction. Log base 5 of 1/3. Got a fraction, we're good, we got a quotient. So we can separate this, we can expand it, and this will become log base 5 of 1, top, minus log base 5 of 3, the bottom number, the denominator. And I'm done. So as long as we have a quotient, we have a fraction in this part of the log, we know we subtract the logs with that same base. Here we go. We have a quotient. So this is going to become log of m minus log of 7. Any questions on condensing or expanding using the quotient property? No. Okay.
Oh.
So last property, it's called the power property. Okay. So this is basically saying if I'm taking the log of something that has a power, right? So a log is an exponent, and now we want the result to also have an exponent. So it's kind of an exponent of an exponent. And if you remember this, like if we had 7 to the 5th to the 3rd, power to a power. You guys remember what to do here?
You multiply.
Yeah, we would multiply these. This would become 7 to the 5 times 3, or 7 to the 15th. Power to a power, we multiply. So the same thing goes here. We multiply the exponents in this rule, and we're going to multiply the exponents in this rule. And what are the exponents? Well, we have 2 exponents here. We have this little n, and we have the log. Remember, log is an exponent. So what I'm going to do is I'm just going to get this n and put it in the front and multiply it to the log. So log base b of m to the n becomes n times the log base b of n. That's it. I just get that exponent and we just move it to the front. Okay, let's try some. So number 13, let's condense. So now I have 5 times log base 4 of 2. I want to make this into a smaller log. So what I can do is I can do the opposite of what this rule. They give me this, and I want to go back to here. So if I have a number in the front, it's just going to go back as an exponent of m. So we're going to do that here. So this 5 is just going to go back to an exponent of 2. So this becomes log base 4 of 2 to the 5th. Okay. Or log base 4 of 32. Okay. So if you have a number for the log, just slide it into the exponent of your result. Okay. Try number 14. I have a 7 multiplied to a log, so I'm just going to move the 7 to be an exponent of the result. So this becomes log base 2 of x to the 7. I think this is the easiest of the 3 properties. Now you have log. We got this 1/3 times log 8. I'm going to move this 1/3 to here. So we have log base 10, right? You don't see it, but there's a base 10 of 8 to the 1/3. Now, do you remember, it has been a few months, what a fractional exponent does?
I'd be lying if I told you I remembered.
It's okay. It's been a while. A few things have happened since then. I don't know if you've noticed, but yeah. It's a radical, right? Remember, the top number is your exponent, so that would be 8 to the 1st, and the bottom number is your index. And so 8 to the 1/3 becomes cube root of 8, and the cube root of 8 is 2. And so this simplifies to log base 10 of 2. Yeah, if you forgot this, don't stress. If you keep it log base 10 of 8 to the 1/3, that's okay, but just remember that that's a radical where the bottom number is your index, top number is your exponent. Okay, so that's condensing. So let's expand. So this is pretty simple. I just get this exponent and I place it in the front. So this becomes 7 log base 2 of 8. And if I remember how logs work, what's log base 2 of 8? 2 to what power gives me 8?
3.
Yes, so this all becomes a 3. And then we have a 7 here, and this all becomes 21. So when you get older and you turn 21 and someone asks you how old you are, you could say, I'm log base 2 of 8 to the 7th years old.
I'm sure they know what I mean.
And they'll be like, oh, I get you. If they're a nerd, they'll understand. All right. Okay. Now we're getting a little complicated, but we're doing the same thing. We have a 3 here in the front already. It's already there. And I want to get this exponent. And since I'm expanding, I'm going to put this out to the front. But whatever's in the front already has to multiply with whatever I'm putting out there. So this 3 is here. And then x minus 1 is a group. It's going to multiply to that 3. And log base 10 of 4. And so this becomes 3x minus 3 as a group times log of 4. Not pretty, but that's exactly what you do. So if you have an exponent that you're putting in the front, make sure you multiply whatever that exponent is to whatever is already in the front. And if it's an expression, put it in parentheses because that whole expression has to multiply to the log. And then, oh, here we go. So I have the square root. We don't like radicals in logs. We like to keep everything as logs or exponents. And I can't use the product rule if I don't have an exponent. So if you remember what we just talked about up here, right? I'm going to go from here to here because I want an exponent as a fraction as an exponent. So W, well, W has a first power here, doesn't it? Because there's no exponent. And if I have a square root, the index is 2, isn't it? So we can rewrite this as W to the 1/2. Okay, so if you have a radical, look at what the exponent of the inside is, look at what the index is, and just put this on top and the index in the denominator. And so now I have a fraction as an exponent, and now I can just put this to the front, and this becomes 1/2 log base 7 of W. Now, even though this is the easiest property in my opinion, it can't get very complicated if you can't find an exponent or if you need to change a radical to an exponent and you forgot. So are there any questions on the power property?
No.
All right. So next page, I mean, I'm not going to go over all of these, but if you see some here that you want me to do, that you think, uh-oh, that looks way harder than what he just talked about, let me know. So the top 8 are condensing, the bottom 6 are expanding. Are there any condensing you'd like me to do? That look confusing.
Can you go over
now
number
we're putting
24?
them all together. 24. So we have a 1/3 in front of a couple of logs. We have adding, we have subtracting. So let's do this. So let's first distribute that 1/3. So we get 1/3 log base 5 of 8 plus 1/3 log base 5 of 27 minus log base 5 of 3. So we want to work from left to right. So what I first want to do is I don't like numbers in front of logs. So I'm going to move those here. I'm going to condense it, make it smaller. So I want to make this all into one log if I can at the end. So this becomes log base 5 of 8 to the 1/3 using the product rule. I'm sorry, the power rule, power property. This becomes plus log base 5 of 27 to the 1/3. minus log base 5 of 3. And so if you remember this, log base 5, 8 to the 1/3 becomes 2, because that's the cube root of 8, which is 2, plus log base 5 of 3, because this means cube root, and the cube root of 27 is 3, minus log base 5 of 3. Okay, still not done. Still have 3 logs. I want to try to make this into 1. So I'm going to use one property at a time. So the way you simplify these or condense these is you do one property at a time. And if you noticed, I did the power property first. Put the 1/3 on the 8 and the 1/3 on the 27. Now I'm going to look at these two. And since I'm adding 2 logs, that's the product property. So that should become, if I'm adding 2 logs, put them together, right? Slurp them together. So that becomes, I have 2 and 3. So that means I'm 2 times 3, because that's the product property, because I'm adding 2 logs. And so, and I'm minus subtracting log base 5 of 3. That's still there. So let's clean this up. This is log base 5 of 6 minus log base 5 of 3. And now I'm subtracting 2 logs. So that's the quotient property. So now I'm going to put them together into one log, because they both have the same base. And the 6 is going to go on top, and the 3 is going to go on bottom. And 6 divided by 3 is 2, so this becomes log base 5 of 2. That was a good problem because it had all the properties. And that's usually the order you go in. You go, you get rid of all the powers first, all the coefficients, anything in front of the logs first, and then you work from left to right, quotient and product properties. That makes sense? Did I go too fast? All right. Any other ones you would like me to go over? Or do you just want to try this on your own and then send me questions later? It's up to you. Let me know if you want me to go over another one.
Miss, I don't know if it's just on my part, but you're cutting off a lot.
Am I? Oh, no.
Yeah.
So did you not see number 24?
No, that, but after that, when you talked after you got done with that problem, it completely cut off.
Oh, okay. So can you hear me now?
Yeah.
Okay. So any other questions on any of these?
Maybe 32.
32. Ooh, okay. So let's see. So we're going to expand this. So I don't like a radical. So we can actually look at it like this. Log base 3 of 4th root of m to the 5th, 4th root of n to the 2nd. So give them their own radical, right? And now let's change it to exponents. Remember the exponent in here, I'm sorry, yeah, the exponent here is the top and the index is the bottom. So this becomes m to the 5/4. This becomes n to the 2/4, and this is log base 3 of all that. And 2/4 becomes 1/2. So if I want to clean that up, log base 3, log base 3, m to the 5/4, n to the 1/2. And so all I have to do is put both of these in the front, 5/4, 1/2, log base 3 of m n. And so this becomes 5/8 log base 3 of m n. Okay, so if you have radicals, change them to exponents, put the exponents in the front, multiply them together, and you're good. All right, guys, go ahead and try some of these problems. I sent you the solutions, so you can try some of these problems, look at the solutions. If you're still confused, you can send me questions on Remind. Unless you have any other questions, that's pretty much it, guys. No questions? You guys good?
Yeah.
All right, guys, it's good seeing you. Well, good talking to you guys, and let me know if you have any questions. We've got 2 more weeks of work, and then the last week is all catch up and make sure we get all the grades in. It's pretty much over, guys.